printe. Rubber. Ito may lain. Wood, glass. So they are examples of insulators. So naay magpaagi ang kurente na apoy, dili does not allow current to flow. Na kung naay kurente, kung ikapon nato, dili ta makurentihan. Now this time, natay conductor, natay insulator. But there are materials that act or whose properties are between that of a conductor and that of an insulator. Mao nang gitawag nato nga semiconductor. It is a material whose properties fall between an insulator and a conductor. Dili na to siya matawag og conductor, di po na to siya matawag og insulator. Because pwede man siya ma-insulator, pwede po siya ma-conductor. Para walalis, itawag siya semiconductor. So that is actually the foundation of electronics. Usually, electronic talks about, dili lang siya magpaagi og kurente og dili. Talks about something or a material that is between a conductor and an insulator. So silang tanan, semiconductor. There are two. Dili lang siya two, but the most popular are two. The most common semiconductor elements are the silicon and the germanium. They have these properties. Now the most important here is that both four elements have four valence electrons. What are valence electrons? Just in case dili familiar, or if familiar siya, mag-review ta kadyot. So a valence electron is, for example, morning atom. At the center of the atom is the nucleus, right? In the nucleus are protons and neutrons. Around the nucleus are the electrons, di ba? Buot ra na kuha ka ng number of electrons. Sample. Yung kaning electrons nga nagtuyok, they follow a certain path pagtuyok nila. Of course, dili jud siya ing ana ka circular. So there is another layer here of electrons going around the nucleus. Kaning valence electrons, these are the electrons on the outermost part of the atom. Siya ang naa sa pinakalayo. If the material is a conductor, usually they would have around one. A very good conductor would have around one valence electron. A semiconductor would have a good insulator would have 8 valence electrons. So ang conductor, very good conductor, nga siya isa ka valence electron. Ang insulator would have 8 valence electrons. Kaning semiconductor that falls between a conductor and an insulator has 4 valence electrons. So both silicon and germanium have 4 valence electrons. This one is one property of semiconductor. So now siya 4. A stable atom has 8. Di jud siya mugtarong, di jud magdagandagan iyang electrons. Now, for a silicon man ang example nato has 4. Kaning itong diri. Kaning puti shows a absence of electron. Now, there is a need for electron. So the electrons are, valence electrons are kani 1, 2, 3, 4. This. So, isa ra di siya ka atom sa silicon. Now, if for a silicon material, there would be a lot of silicon atoms. So, a silicon material is shown in our right. So, this is a silicon atom. Isa siya kabuo. Kanang naa diha sa kilid. Those are the valence electron. What happens here is that upat ra bang kabuok no. So what happened here? Nganong di naman ni siya upat? 1, 2, 3, 4, 5, 6, 7, 8. So na siya upat and it is siya borrow. It shares its other 4 valence electron with the valence electrons of the nearby silicon atoms. Naget siya. O sa naasa siya, ni borrow siya isa dire. Borrow siya isa dire. Borrow siya isa dire. Borrow po siya isa dire. The same is true with the other silicon atoms. So now it has 8 valence electrons. So a silicon by itself has 4 valence electrons. But when it is with other silicon atoms, the silicon material would now be an insulator. So although this is called a semiconductor, pero kung pure jud siya nga silicon, it acts like an insulator because now atoms would have 8 valence electrons. There. Through the process of covalent bonding. Kani siya. Nagtapot sila by sharing electrons. A semiconductor does not only exist as an element. There are compound semiconductors also. Examples here are gallium arsenide. It consists of a gallium material and an arsenic material. So when these atoms are together, tawag siya gallium arsenide, and they bonded also using covalent bonding. There. 5 siya, kani siya, 3. Almost like a semiconductor. Pero they can act like a semiconductor when they are together. And the material, we call it a crystal. Ito siya, crystal po di siya. We call it a silicon crystal. Kani siya, see, is also called a crystal. So when for example, silicon, if it is a material that is consist of only, or if it is a semiconductor that is consist only of the semiconductor lang, silicon only, we call it an intrinsic semiconductor. It is a pure conductor, siya ra jud, why nasagol, free from impurities. And then, if sagulan siya of impurity, other substances are added to the semiconductor is now called extrinsic material. When impurities are added, the process of doing it is called doping. Ox, masabtan na no? Kung siya ra, intrinsic. Kung sagulan siya, extrinsic. And the process of adding substances to a pure semiconductor is called doping. So if it is already an extrinsic material, the material is already doped. Dili na siya dope nga drug sa Daw na siya in the context of semiconductors. Let us look at the energy levels of the electrons. So, kaning electron, di ba nagtuyok siya? Nucleus, na ay electron, Umao ni siya, kanang nasa ubos sa figure. Naadiri ang nucleus, and it would have electron diri dapita, electrons nga moagi diri dapita, electrons nga moagi diri dapita, electrons nga moagi diri dapita. The farther are the electrons from the nucleus, the higher is its energy state. So kaning electrons nga naa diri sa pinakalayo sa nucleus, tas iyang energy state, kuha ni siya, kanang, di siya mahimutang. Lihukan kaayo siya. Mo ni kipasabot ani. And for an electron to transfer to another outer layer, example lang ha, pero usually they do not move to an outer layer. They have to absorb a lot of energy. Kay kinahanglan mo siya, diri nga level sa imabaw, kinahanglan mo siya taas nga energy. Pagbalik siya dito, it needs to absorb a lot of energy. Kung munaog siya, it needs to give up a lot of energy. Kaning nasa ibabaw, diri, di na ka na kay siya energy, kay siya may nasa kinalayuan. The tendency of this valence electron is that if we add an energy ba to our material, the valence electron tends to escape from its atom na. Kaya taas naman niyang energy, taas na iyang energy daan. Can we energize it? Example of energizing it is by adding heat, right? Another way is by adding a voltage, a potential on the material. So that is why naikurente mo gawas. Diba? An example is, of course, the conductors. Dali ra kaayo mulihok ang kurente sa metal, ang electrons sa metal because the electrons are loosely bonded with the nucleus or with the atom. So kaning sa semiconductor, same lang. Ang katong outermost layer nga electron, dali ra sa kay siya. Lihukan tayo siya ba? Kamay na kuwang, sibat na siya. So that is the concept why there would be a flow of electrons. Katong naa dito sa kanang naa sa ilawom diha, nagtapot yun na siya sa nucleus. Katong ang maglihok-lihok lang katong electron ra naa dito sa kinalayan. O energy level gihapon siya. So for an insulator material, this is the valence band, di ba? Mga valence electron. It would take a lot more of energy for the valence electron para maka-escape siya to be free. Kani conduction band, this is that, so tawag na to ini. Mauni siya, this is the highway nga magdagandaga ng electrons. A moving electron is current. Ang kani conductor pod, ang valence band niya o ang dagananan dan sa agianan sa mga kurente nag-overlap. Ang kaning sa semiconductor, igo-igo ra jud. So kaning sa conductor, gamay na lang pagbutang sa kurente ni dagan ng electron. Kani siya, it needs to absorb a little bit of energy more than the conductor. Naa siya. For a silicon, 1.1 electron volt. For a germanium, 0.67 electron volt. For a gallium arsenide, the energy that the electron would absorb should be 1.41 electron volt. So when ano man ang semiconductor dayon nganong add man siya o impurities. O nagipasabot niya. This is the process of adding impurities ha. Now, the purpose of adding impurities is to alter the properties of a semiconductor. So we can control its energy level na iya ma-require. And others, iyang resistivity. We can control it by adding impurities to the semiconductor. So, giunsa man din siya. So, depende sa amount nga ito is i-dope, it can define the characteristic of a semiconductor device. So, when we add impurities to a semiconductor, we call it extrinsic. There are two types of extrinsic semiconductor. The N-type and the P-type. When we add substances, either there would be an excess of negative charge or an excess of positive charge carriers. Kung daghan negative charge, then we call the extrinsic semiconductor an N-type material. If it has a excess of positive charge carriers, then we call our extrinsic semiconductor a P-type material. Dali ra siya mahinumduman. Diba? So how do we add impurities? And how do we make it a P-type material or an N-type material? If these pentavalent materials are added to silicon, for example, or germanium, what's the meaning pentavalent? Penta is 5. If we add these elements whose valence electrons are 5, example, pentavalent materials, antimony, arsenic, and phosphorus. Taas siya 5 covalent electrons. What happens is that, kani ang phosphorus ha, 5. So what happens is that, ang silicon, it has 4. Diba? And then, dungaga na to substance nga 5 ang valence electrons. So how many valence electrons would there be? 4 plus 5 is 9. 8 raman to be stable. So ito yung may tabuan ni, we have 1, 2, 3, 4, 5, 6, 7, 8. Asa man ika-9? Na ang ika-9 ay sobra. So we call this sobra. Na, it doesn't belong to any atom. We call this the free electron. This free electron would always look for a place for itself. Duhaga na pudlayan na to. Phosphorus na pud ni. Diri. O nasa siya another free electron. Napailain dito nga mga phosphorus. Nasa siya another free electron. Mao din gipasabot nga excess of negative charge carriers. These negative charge carriers, di siya mahiluna. O siya kabutangan. O siya dito sa outermost layer. Mangita din siya paagi. Asa siya mo lugar. Ox. So, extra negative charge carriers. That's the negative charge carriers means the excess electron in the material. Now, if our dopant has 3 valence electrons, they are called trivalent materials. The popular dopants are boron, gallium, and indium. So, kani sila, 3 lang ilahang valence electron. They're called the acceptor atoms. Ang nagtaod niya, Let's say mo ang boron. Pila siya? 3 valence electron. Plus the silicon, valence electron 4 kabuo. 3 plus 4, 7. 1, 2, 3, 4, 5, 6, 7. Right? Naadiri, wala. Kulang siya o electron. This area here would always try to attract electron. Gets? Pwede ka din siya. Mubalhin dito. Kulang na pud na. Attract na po siya glayin electron. So see, we call this a hole. Murag buslot ba? Oh, where electrons are desired. Diba? This makes the material a positively charged material, or there is an excess of positive charge carriers. We call it positive charge carrier because it's always attracting electron, a negative charge carrier, diba? So if, mo na itong giingon, if sobra electron, N-type material, kaya sa ubos. Kung kulang electron, we have a P-type material. If we have a P-type material, and we join it with an N-type material, itapad na to sila. We now have a PN material. Between the PN material, we call it a junction. The combination of a P-type material and an N-type material results in a junction. I don't know, I'm not sure. I think yung kipasabot. The junction where the P and the N-type meet. So when these two materials are joined, at this area here, kaning area diri, na siya excess of electron ang isa absence of electron. Kading area diri nga nagtapot sila, the electrons and holes would combine. So if we join them together, between them, there would be no excess or no lack of carriers. Kani siya, sa N-type, a lot of negatively charged carriers. Ang kaning sa P-type, a lot of positively charged carriers. Between them, nag-recombine naman, nagtapot naman ang holes o ang electron. So there is no free carriers anymore. We call the region kaning between them, kung asa nagtapot ang electron o ang holes, we call that the depletion region. I think naananita ng sariling material ha. And also if you would read it, in some other electronic books, the same. Pwede rabi sa unsa nga electronic books kasahon. Sus di araman di ay akong gidrawing. Sindot ni kay forma. So this part here is N-type material. This part here is the P-type material. Between them, pag itapot silang duha, this part here, ipon na to ang buslot ug ang sobra nga electron. Kaya isa sobra, ang isa kulang. So this part here is becomes a neither N-type or P-type material. Dili siya positive, dili siya negative. Neutral na siya. Ano gipasabot? This part here is also called the PN junction. So the material, we call the material, this entire material, the semiconductor diode. Of course, di siya ingana kadako ha. So we call this a diode. Mo ng title sa ato chapter. So what would happen if to our diode? Butangan na yan nag-wire diha o pisa na siya. It's an electronic component now. So kung pasagdan lang nato ang diode, we do not add any voltage across it, then there is no current at all. There is then we have a depletion region at this part. Kung magpatara lang siya ba, nothing. Okay, mao na itong illustration. So, nina sa ubos. Bias means applying a DC voltage. No bias means zero voltage. Kanina sa ubos. So, this is the symbol. If we look at an electronic diagram and we see this is the diode. Kung naa na siya sa electronic diagram, then kana siya gipasabot ana. That's the diode. It's a PN N-type material nga gitapot. So if we draw a diode, butang anak sa kilid ha. Diha. Diode na siya. This part here is called the P-type material. The end where the P-type material is connected, we call it the anode. The N-type material, N, is called the cathode. And we would know that this N here is the anode. Kung tanaw mo siya, wala siya A. Right? That part nga, nagtakilid nga A, that's the P-type material. And that is the anode. Kanina sa PCAS, called the cathode, kabalo po ta, kabaw na siya ang cathode. Kaya anode ba ang PCAS, di ba? So anyway, because it is I K, bali lang ang K. So that would be the cathode. That's the N-type material at this end. So anyway, what if we add a voltage on our diode? There is a P-type. Asa ang P-type? This is our P-type material. This is our N-type material. If we connect a negative here, and then positive here, what happens is that the electrons would be attracted to the positive to the right, and the holes would be attracted to the negative potential to the left. Right? O mo na nagtapot sila dito. So what happens to the depletion region? The depletion region, which is supposed to be naara sa tunga, it would widen. Right? A depletion region is neutral. Dili siya positive, dili siya negative. It is like an insulator. So kung balihon na to connect ato ang potential, then there would be current there will not be any current that would flow. Eh, nag-ihay mo sila dagan dito, right? And the depletion region has no current at all. So what if we reverse the polarity of our voltage? What would happen? So there is a P-type material. na ang positive. Diri sa N-type material naa diri ang negative sa ato ang voltage. What happens is that ang kaning mga electron diri sa N-type material would get attracted to the positive potential here. Mulabang siya. Ang kaning holes sa diri, mga holes would be attracted to the negative potential of the voltage. Mo-attract siya dito, mudagan siya dito. What happens now to the depletion region? Nga naa man unta tay depletion region diri. Due to the energy that is applied, kaning mga karyer banggaan na nila dito ang depletion region. Wala na depletion region. Mudagan-dagan na sila dito. Dagan-dagan doa. Mudagan-dagan na sila dito such that a current would now be able to flow across through the diode. So a diode is kung balihon ni taod ang voltage, walay current. Pag imong itunong nga sa P-type material dito ni nato ibutang ang positive. Sa N-type material dito nato ibutang ang negative, then nanatay kurente. I think the logic is sa yun lang. Taas lang kaya ko ang pagka-explain. So the diode has this magnitude. The current through the diode, I is current. Talas nagdidiha. To indicate that it is the current flowing through the diode is equal to I of S times E to the VD. V of D is voltage across the diode. K is a constant. K depends on the type of semiconductor that we use. 11,600 over 1 for germanium, 2 for silicon. T here is temperature. So from the equation, we would see that the current depends on the voltage across the diode and would also matter if the temperature would also affect the amount of current that is flowing through the diode. What is IS? IS is the reverse saturation current. I think na siya dire. What is a reverse saturation current? Reverse saturation current are the flow of minority carriers. Ang magsabot minority. Mauning N-type material, diba? Naa siya'y daghan electrons. Negative. Although naa siya'y electrons daghan, there exists a very small amount of holes. Nasa siya hole, nga saag-saag. Because it is an impure material now. Sagulan man siya, na siya. Gamay ra ha, didaghan lang kay para makita. For an N-type material, the majority carriers are the electron. The minority carriers are the holes. Ano yung pasabot niya? Majority ni siya. The P-type material, bali, the holes are the majority, the electrons are the minority. So anyway, when there is a current, magdagandagan man ng electron, magdagandagan sa ding holes. So there is a minority current flow, carrier flow. This is the reverse saturation current. This is due to the minority carriers. So a diode, to describe its operating a characteristic, it is described, to describe its operating characteristic, makita siya sa characteristic curve. Characteristic curve is the plot of input-output relationship of a device. So in this case, the input is the voltage. X-axis is the voltage na P, and the output is the current. IF ang gitawag diri. IF if it is forward bias, IR if it is reverse bias. Nasa ubos IR, nara diri sa positive side ang forward bias. So anyway, bigyan sa nato ni pagkuan. Let us look at the diode characteristic curve. Ato sa i-describe ha, then we will have a short break. Stretching ka. Kita kong hawak. So if there is no voltage, diri dapita. No current, zero current po, zero voltage. If we increase the voltage, P-type material, dito gibutang ang positive. N-type material, dito gibutang ang negative. We call it the forward bias. Kana. Then we increase the voltage slowly. Na. Like current, gamay. But when it reaches a certain voltage, ang gibutang diri, 0.65 volts for the silicon, 0.2 volts for the germanium, the current would increase largely. So gamay ray current pag increase, pag makaabot siya, ani nga current o ani nga voltage, saka na dayon iyang current. This is called the on voltage or the threshold voltage. If we reverse bias it, ang sa P-type, negative ang ibutang, ang sa N-type material, positive, gamay ra kaayo current. We call it the reverse current and cute kaayo in terms of microampere. This is not drawn to scale ha. Ang scale diri sa pikas di parehas wala. So kung balihon na to ang diode or ang voltage, dili siya, wala siya kurente. Let's say for example, we apply 10 volts. Of course, no current. We apply 20 volts. We apply 30. We apply 40. We apply 50. Increase, increase, increase. And there comes a time, maguba na natong diode. Uy, hindi na siya kasagang. Di ba? So until that time, kung asa ang maximum na makasagang ang diode, we call this voltage the peak inverse voltage. Akong spelling. Ay, basig putol-putol atong internet. Peak inverse. Pali pa ka inverse. Kanin siyang dapita, guba na natong diode. We call it the breakdown region. This part here is, the diode is guba. However, naa siya gi-indicate diri. There are special types of diode na kung balihon, naa siya voltage. Kadang voltage, pag maabot na siya, inverse voltage siya, pag maabot na siya, the diode is dili maguba and the voltage is maintained at this part here. Pakapin na siya diha. Usually, maguba na ang diode, but there are special types of diode nga pag abot ada niyang dapita, i-maintain niya ang voltage. Those are the diodes that is used for ang voltage regulation. Special diodes na siya ha. The regular diodes is maguba kung balihon and the voltage is so large. Large nga tuda na jud. Ita kasagang. So this part here, governed by a special type of diode, this part here is called the Zener region. Mao nang VZ. Let's take a short break, mga 5 minutes lang. Ayaw pagpalayo sa inyong terminal ha. Pag stretching po, dili mo lingkod ra. May na lang, mutubo pa ka. Let us continue. So at the Zener region here, this is only true for special types of diode. When we reverse bias it, there should be no current. But if it reaches a certain voltage, then there would be a sudden flow of current. Mo ni siya, although in the opposite direction. Diba? Kaya namin diri siya sa negative. We call this the Zener region. If it is too negative, a certain voltage causes a sharp change in characteristic. There would be a release of carriers. Kaning release of carriers po, hindi pasabot niya sa kani current at this part here. So this point is called the Zener potential or the Zener voltage. Potential is sometimes used interchangeably with voltage. So sometimes I use electric potential instead of voltage. Pero parehara na, ang akong ipasabot, I'm not sure kung parehas yun na sila exactly the same, but in this case, when I discuss it, they are used interchangeably and they mean the same. So this is still the diode characteristic curve. This shows the diode's curve in different temperature. This is for 125 degrees. I'm not sure if klaro ba siya on your end. This is 25 degrees Celsius. This is 75 degrees. So if we notice, for different temperature, ambient temperature, the curve would shift. So if at higher temperature, the threshold voltage is lesser. So meaning it takes a lesser voltage to turn on the diode. At decreased temperature, ay di na siya nag-75. This is negative 75. At cold temperature, it would take more voltage to turn on the diode. Same, there is a reverse bias region. If taas ang voltage, there would be the breakdown is higher. Diba? Breakdown voltage. And at lower temperature, the breakdown voltage is lower. The area between them is the room temperature. So anyway, diodes are also sensitive device, sensitive to temperature. Semiconductors are temperature sensitive also. So semiconductor siya, di sensitive siya sa temperature. And I think the same with other materials, right? A resistor, resistance, utro-utro po siya, depende sa temperature. So as we look at it, the diode can be turned on if it is forward bias, because if it is forward bias, then there would be a current. But then, if we reverse the polarity of the potential across our diode, it is now in reverse bias. No current would flow. So, sa pasabutan na, the diode is just like a switch, right? So what is a diode as a switch? It is similar to a switch. Parehas siya because it will allow the current to flow and then pwede po dili mo apagyon niya ang current. However, it is different from a switch because the diode would only permit current to flow in one direction. Kaya kung switch pa siya, may Sa symbol sa switch kadto ha. If this is our switch, namang switch. Ana ang switch, di ba? This is an open switch. If the switch is open, then walay current, right? But when we close the switch, for example, current would flow. The current can flow this way. The current can also flow in the opposite direction, right? But for the diode, forward bias siya, positive diri, negative diha, di ba? Then a current would flow, right? Then the diode is on. However, if it is reverse bias, the reverse bias if we put a negative potential here and a positive potential here, then no current would flow, right? So, technically, ang current niya, isa na dyan siya ka-direksyon, di dyan siya mabalik. Kaya kung balihon na to, di man niya pag-on. So, a diode as a switch, in comparison to a mechanical switch, is the same in a way that it can be turned on and off to allow a current to flow, and when it is off, it doesn't allow current to flow. However, it is different from an ordinary switch because for an ordinary switch, when it is on, current can flow in both directions. However, for a diode, when it is on, the diode would only flow in one direction. Hindi siya mo bali ang current. Kaya kung balihon, awa na, ma-off na siya. Right? Ay, naara di ay. Oh, see? In the forward bias, it's an on switch. In the reverse bias, it's an off switch. So if we look at a diode characteristic curve, again, it will turn on around this point, right? Now notice, medyo slanting siya. The slope of that curve is the reciprocal of the resistance of the diode. So this also describes if the diode is this physical entity, nasa siya resistance? Kita lang material na may resistance. So the resistance of a diode is computed as same gihapon from Ohm's law. It is voltage across the diode divided by the current across the diode. Of course, at this part, lahi iyang resistance. At this part, lahi po iyang resistance. Right? And since the curve is not linear, it does not have a constant resistance. Pero kaning diri dapita, it looks like a straight line naman. So the resistance can be approximated. Ano may ana siya diha. Now, however, this is for direct current. What if the applied voltage is in AC? The voltage is changing. Therefore, if the voltage changes, nasa ubos, the current would also change, right? What would be the resistance of the diode if an AC is applied on the diode? So, gikuha na lang ang tangent across this change, maximum and minimum, kuha siya diri, diha. And then, differentiate, we make the difference as small as possible. So the difference in voltage divided by the difference in I, we made it so small that it becomes the derivative. So kung kompleto na siya, tuda-tuda, the resistance is equal to 26 millivolts divided by the current across the diode, the DC component of the diode, DC current component of the diode. This equation is useful if especially when we have later on, we will have transistors, and transistors can also be modeled as a diode. And most transistors um, deals with changing voltages. To make it simple, we use an sinusoidal signal. So, model siya ang iyahang dynamic resistance of that parts of transistor where it is modeled as a diode. So, these are diode approximation. So, if we look at a diode, ideally, dapat yun ang diode, when it is reverse bias, there is no current there. Right? If it is forward bias, kung dili na to i-reverse, then current would flow. And the diode will not have any voltage across it. Kung ato ni siyang measuron ang voltage, diha, zero voltage kay kuan naman siya. It's like a short circuit. Wire man siya diretso, di ba? So it is, the x-axis is at zero. But anyway, we know nga the diode will not turn on right away. It has a threshold voltage. So if we consider the threshold voltage, the approximation of a diode is likened to a simplified model shown here. Reverse bias off siya, but when we forward bias it, there is that part in the forward bias where the diode is still off. No current sa. And then pag moapot na siya, adang threshold voltage, then the current would start to flow. So if we model it, we have the diode here, ideal diode, plus that voltage that the applied potential needs to overcome. Diode, if we consider the resistance of a diode, we call the approximation a piecewise linear model. Reverse bias, zero current, but when it reaches a threshold voltage, current would start to flow. But not vertically, slanting siya. That is due to the resistance of the diode. So this piecewise linear model considers, of course, the diode as a switch that allows it to be off and on. But kung on siya, only one direction. There is also a need to overcome the threshold voltage for the current to flow. And the diode also has a certain resistance. Usually, we use for simplicity purposes, because simplicity is beauty and easy, we use the simplified model. I think reading material 1 has, wala makayo sa computation. Ay, computation, pero graphical. We use this, right? So the threshold voltage would depend on the type of diode that is being used. If the voltage surrounding the diode is so large, pwede na to gamiton ang ideal model. Because kung silicon siya, the threshold voltage is 0.7. Now, if we are dealing with 200 volts, kanang 0.7, muta ra na siya. So we can use the ideal model. Pwede. Unless the problem requires or makes express na unsa nga model gamiton. Now, when a diode is subjected to an AC, a changing voltage or changing current, balik ko na kung drawing ang diode. A diode na lang. Ana. Diba? P-type and an N-type. At the junction, we have the depletion region. The depletion region is an insulator. It has no carriers. Kaya ang atong electron ug ang holes nagtapot na. So it's neutral. It's like an insulator. Kung ato siyang i-approximate, this can be modeled like a capacitor. Diba? The capacitor between the plates is an insulator, a dielectric material. A dielectric material does not allow current to flow. So it is like a capacitor. So a diode, when subjected to a very high frequency, would have a capacitance. At reverse bias region, the capacitance is the capacitance that has a large value there is called the transition capacitance. At the forward bias region, this is the reverse bias region, the forward bias region, the capacitance there is that of the diffusion capacitance. Of course, both exist, pero mas dako nga value ang diffusion capacitance at forward bias, and in the reverse bias, the transition capacitance has a larger value. This is when the diode is used in a high frequency environment. Example lang, yapay lang siya ani because of the characteristics of the diode. The diode might not act like as expected, maybe due to its capacitances. O di-mention siya. At very high frequency, because at very high frequency, the capacitive reactance is equal to, if we try to review high capacitance, the capacitive reactance is equal to 1 over, all over 2 pi Fc. F is the frequency. So at very high frequency, the reactance decreases. So instead of the diode acting like a diode, semiconductor, the diode might act like a conductor at very, very high frequency. I would like to emphasize that. So di na siya diode, wala conductor na siya. So if we model it, model ba, tulong-tulong ba? Press ani. Yeah. So if we model it, the capacitances would be parallel to the diode. Another characteristic of the diode, when the diode is subjected to very high frequencies, its reverse recovery time. If you make the diode kuan ba, of course, the diode, when you turn it on, nasa voltage, di ba? When you turn it off, ideally, zero current di siya diri no, nasa tunga, na kay current. When you turn it off, when you turn off the diode, the current would be zero, right? Now, actually, kung you have a current, that's the, imagine na nimo nga ang electron, naglumba-lumba sila dagan. And then suddenly, imong balihon you turn it off. So of course, nagdagan sila, lumba sa sila hunong. Sila kasagang, naghunong nila masubrahan. Maybe they are running too fast. Anaan na lang analogy They're running too fast. When you turn it on, mo reverse ka jud ang current. Munaw siya, instead of stopping right there, nagdagan man sila, you make it stop right away, mula pa siya gamay. But anyway, of course, mo zero jud na siya kay gi-off man nimo. Gi-off man nato, di ba? So, we call this from lapas mo siya gamay, the time it takes for the diode to actually become zero, we call it the reverse recovery time. This part here. Kani nga part diha. Now this is not too significant for ordinary applications because the reverse recovery time is So short, nanosecond to 1 microsecond. 1 nanosecond is around 1 times 10 to the negative 9 second, di ba? Microsecond is around 1 times 10 to the negative 6. Mas paspas pa na sa ato ang blinking. But anyway, again, the diode, an ordinary diode in its operation may not act uh, as expected at very high frequency. Nga naman, if we consider the reverse recovery time, morning diode, atong i-off, di ba? It would take a certain time for it to be actually off. Now, at very high frequency, you turn off and you switch the diode at so many times, right? Kay high frequency man siya, kadaghan. Wa pa gani siya ka zero, gi-on na pod nimo. Napa siya diri, gi-on na pod nimo. Dayon, gi-off na pod nimo. Dayon, gi-on na pod nimo. For example, ana ba? And you make that time too short. Di ka adjust ang diode, oy, maglisod siya. Total, imo ka galingon sa diode, di ba? If you make it too fast, right? Di ba, in digital, it's on and off lang, 1 and 0. And you make 1 and 0 too fast. So if our component is a diode, kasagang o itong ordinary, there are special types of diodes for high frequency such that they also have a very good frequency response. Anyway, that's a limitation of a diode, or that's not a limitation actually. It's a, ano lang, kay physical entity man siya. That is one factor that we have to consider also. The manufacturers, kadang pigbuhat sa diode, they provide specification sheets about their product. So, naa siya pakapin, puro siya manual sad pa. So, of course, when we buy a diode, wala siya pakapin nga specification sheet. Sa una, the manufacturer has a book na dito tanan niya nga pisa, with including ang characteristics of its components that it makes. Karon, we can readily see the specification sheets of diodes and other electronic components. Dali na siya I think i-google siya, naapot siya sa site sa mga manufacturer. So ako na siya gibutang. There is a sample specification sheet in reading material 1. This is the diode nga gidrawing ganina. This is the schematic symbol of a diode. We know that this part is the P-type material, kay mura siya A. That's the anode. The N-type material is the cathode. It looks like a K kanang end. So anyway, if you know that the one end is anode, of course, because cathode na. Sila raman duha. An actual diode has a marking, usually to indicate asa ang cathode. Usahay ani ang dot Y. But the diode is so small, hindi siya madruwingan. So usually na siya bandihan. Bukakan siya gray or silver. Usahay itong kani, duwingan ba nila linya diha, then we will know that that is the cathode. Usahay na uban, dot lang or K. Na marking, usually the marking is on the cathode end. This is the dot Y. This is around this size in centimeter. So, around, kailan 1 centimeter ni. The smaller part is less than a centimeter. The larger part is usually a higher wattage diode so that it can withstand larger amount of current. But a diode, sa electronics, usually the current and the voltages are so small. I think dako na ang 24 volts. Na 60 pero panagsara. So these are the different types of diode. So see, example kani, this part here is the cathode. Anyway, the specification sheets also indicates asa ang cathode ug ang anode. This is the lead, kanang magsiga-siga nga suga. That is also a diode, a light emitting diode. Ay naa. So another special type of diodes are the light emitting diodes. When a object is energized, there would be movement of carriers. And since it absorbs energy, it would also radiate energy. One type of energy that it radiates is heat. Mainit man siya. Kung masobrahan, awat na sunog na itong pisa, di ba? Another energy that it radiates is light energy. That is the light emitting diode. They are energized, when they are forward biased, they give off light. Hence, they are called the light emitting diode. The light that it gives off is either visible or invisible. Kadang visible, kadang mas kita na to ni siga. Kadang invisible, kadang sa remote control sa TV, dili ba na mo siga gud ang LED diha sa tumoy? But there is a light there nga mogawas. However, the wavelength is not visible to the eye. So for different material, different colors are produced. And these colors and these materials requires different threshold voltage for it to energize. Ox. Different from silicon and germanium, of course. In silicon and germanium is maniga. So I'm not sure. Napatingali additional color ani no. Panahon pa ba ni sa mampuro ang libro? So, kani siya. When it is energized, they would radiate light. A symbol of a light-emitting diode is diode siya. Makabalo ka that it gives off light because it has arrow pointing outward. So kung naa siya sa, if we look at an electronic diagram, naana siya, of course we know that the diode. Pag naay arrow pointing outward, it's a light-emitting diode. Musiga na siya. Kadang gi-drawing diha sa diagram is musiga. The light-emitting diodes are also used in 7-segment display. Kanang musiga ha, dili ang kanang liquid crystal display. Kanang musiga, those are LED. Of course, gipurma sad og straight sa ang iyahang part ka musiga. Da. Ay, humanata. I think I have already posted. Please answer the problems or the questions at the end of reading material 1. Practice. And also, I posted names of those who will present some of the numbers of the questions at the end of the reading material 1. It does not mean nga katong inyong answeranan nga number, maura tong ansiran ha. Please answer po sa makaya sa powers. Kadang powers jud nga very strong power ninyo ha. And also katong wala po ma-assign, basa-basa sad, ayun answer sad. And also, we might have a limited face-to-face activity this semester. And 2 of the requirements are, number 1, you are fully vaccinated. So please, I think I posted it po in the form of an assignment. Please submit a copy of your vaccination card. And also another requirement is PhilHealth membership. Please also submit a copy of your PhilHealth membership. Not in this class, but someone, I think in my other class, asked if pwede na ba ko no dili magpa PhilHealth member. kay naa na siya health insurance. I'm not sure, pero if you would ask ask UC or anybody authorized to answer that in UC, I think you have to check first if your health insurance covers kanang COVID cases. I think that is all. Any other concern? Si Nineria is asking for a PowerPoint. I think dili si Nineria mga there are others po. I-copy ra ba na po siya sa libro? Either i-copy na ko din sa libro ang PowerPoint or the PowerPoint na akong ikapihan ani is based on the libro sa reading material 1. And I will not share this kay kinupya maganda ko na yung uban part sa PowerPoint. I cannot make a copied work, distribute it pa jud. Wala ra ba na ako gibutang peri. Hindi na acknowledge sa akong gikapihan. I'm sorry, but please read reading material 1 added tanan. And also you can read other electronic resources. And there are a lot of I think lecture videos put in the internet. Please let me know kung naay conflict or ako'y nasayo. Kaya ato ang i-try o reconcile. Any other questions? Kung wala na questions, pwede na mo exit. Thank you for your time today and have a nice weekend. Dili tomorrow. I thought we would need 2 meetings this week. Dili na tayo mag-meet tomorrow. Sige, bye. Salamat. Unsa tong gisulti? White tao.